Hello, this is Charlene. We are going to be talking about finding the domain and the range of a square root function. This video is going to be a little bit lengthy because there are several things I need you to understand about square root functions. The first thing is, what is a square root function? This is a square root function. It says square root function. It is y is equal to square root of x. This is what it looks like. It starts at 0, 0, and it is like a curve. And if you were to finish the curve on this side, what does that look like? That looks like a parabola sitting on its side. But the thing is, though, is that they do call this a function. So if we included this lower part, it would cease to be a function because it would not pass the vertical line test. It would hit the function in two different places. That disqualifies it for being a function. So that is the reason why the function does not exist in the negative area for the y values. That's the other thing. The y value is the function value. So when it is a function, a square root will never equal a negative number. So that means that the function, or the y values, will never exist in the negative range area. All of these y values are negative down here. And so your function value will never exist in that negative area. Otherwise, it ceases to be a function. So I hope that makes sense. Let's get rid of all this stuff so we can talk about the next thing. Okay, get rid of that. Let's make this smaller. Okay, la 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 la. It's not making it smaller. Why is it not making it smaller? Okay, there we go. Okay, so the next thing I need you to understand is, can the answer to a square root be negative? This is more of the same, but this is kind of explaining it with words. It says, no, the principal square root denoted by the radical of a positive real number is always a positive number by definition. However, a number can have both a positive and a negative square root. For example, 3 and negative 3 are square roots of 9 because 3 times 3 equals a positive 9 and negative 3 times negative 3 equals a positive 9. When solving equations, you must consider both possibilities, but when the radical symbol is used, it refers to the principal positive root only, which must be a positive number. So that may not make complete sense at this point, but hopefully you'll understand where this information fits in as we continue to look at the square root. Okay, we're going to find the domain and the range of the function f of x equal to square root of 16 minus x squared. Well, the first thing I'm going to do is exchange this notation f of x for y, just because it's easier to work with, and I can do that. Okay, and I've done that right down here. I've already put y equals square root of 16 minus x. So we're just going to use order of operations, and we're going to work this down. So how do I get rid of this radical that is around the 16 minus x squared? Well, I'm going to square it. Well, if I square one side, I also have to square the other side to make it balanced and equal. So the square root literally cancels out the square, and I'm left with this here. Y squared is equal to 16 minus x. And now I'm actually going to add the x squared to both sides. X squared, x squared. Okay, so these are going to disappear, and that leaves me with y squared plus x squared equals 16. Now, I'm like I said, we're going to do it a different way here in a few minutes, but I want you to look at this and try to understand what we can recognize from this. So y squared plus x squared equals 16. That is actually the equation of a circle. If you remember correctly, the general equation of a circle is this right here. It's x minus h squared plus y minus k squared equals r squared. And of course, in this particular circle, it means that the h and the k are actually going to be 0. H and k are going to be 0 because x minus 0 is just the x, and y minus the k would be just the y. So this is a circle, and its center, because the h and k is going to be the center of the circle, that means that it's going to be at the origin. It's going to be in the center of the circle. That's going to be the center. And 16 is equal to r squared. So that means 16 is equal to r squared. And if I square root both sides, that means that the radius is actually equal to a length of 4. So this is what it's going to look like when we graph it. We're going to graph it, and it's going to look like this. And it means that this number here is going to be a 4, and this is going to be a 4. Oh, that's going to be a negative 4, actually. This is going to be a negative 4, negative 4. And this up here will be a positive 4. So that's the circle, and the center of it is here at 0, 0. Okay, so what we were talking about up here, this is where you need to think about this. The square root can only live in the positive space, right? The square root function cannot live in the negative y space. The function is the y value, so we can't have any y values. So that means that all of this stuff down here cannot be included because we're actually talking about a square root. So that means that we would actually end up with just this graph without the y values in the negative space. So from this picture, because like I said, we just got to recognize it's a circle, recognize that we cannot have any negative values for the y range area. Okay, so I can now figure out what the domain is. Okay, so the domain, which has to do with the x values, which means from left to right, because the x-axis goes from left to right. Okay, so where does the graph exist? Where does the function exist from left to right? Well, it starts right here, which of course we said was like negative 4, right? And that's on the left side. And then goes to the right side. Well, it ends right here, which is a positive 4. So that means that the domain goes from negative 4 to a positive 4. And we do put these brackets, or sometimes I call them hard boxes, and I'm not sure why that just disappeared here. There we go. Okay, because the graph does actually touch those points. So it is actually equal to the negative 4 and the 4. So that would be the domain of that function. And then also we can talk about the range. Okay, let's kind of scoot this over and out of the way for a second. Okay, so the range, which has to do with the y values, range has to do with the y values. The y-axis goes from top to bottom, or bottom to top. So it goes up and down. So it's literally from bottom to the top. Okay, so where is the bottom of my graph? I'm going to go up. Bottom of my graph is right there, which is actually equal to 0, right? So the bottom of my graph is at 0. And where is the top of my graph? The top of my graph is going to go right there. So the top of my graph is going to be right there, which also is 4. So the bottom is 0 and the top is 4. So that means it is equal to the 0 at the bottom, and it is equal to the 4 at the top. So my domain for this square root function that we started out here at the beginning, the square root function, the domain is the x values from left to right, is going to be from negative 4 to positive 4, because it starts here and it goes to right there. And my range values, which are my y values, are from the bottom to the top. So from the bottom to the top, it goes from 0 to a positive 4. Okay, we're now going to look at our square root function in a different way. Essentially, we're going to solve for the x by setting the function equal to 0, which is kind of how we solve quadratics. When we have a quadratics, we factor it, and then we set each of the factors equal to 0. So it's the same kind of idea. The first thing I'm going to do, though, is instead of, I am exchanging the f of x notation for the y, and I've done that here. Y is equal to square root of 16 minus x squared. However, when I set things equal to 0, I kind of like my 0 to be on the right side. That's just the way my brain likes to see it. So I'm going to just flip it around here. I'm going to say the function is equal to y, because when we set a function equal to 0, we're saying that the y is equal to 0, because the y is the function value. So that's what I've done here. I've exchanged y for 0. I'm saying that the y is equal to 0. However, if you notice, I've also added an inequality sign, because, as you remember, our square root function over here is not equal to all the values. It is not equal to the negative values. It is only equal to 0 or greater. So my function, which is my graph, must be bigger than or equal to 0. So here's my function. My function must be greater than or equal to 0. So greater than or equal to 0. So I hope that makes sense. With the square root function, we have to go ahead and enter an inequality, because a square root function cannot be equal to a negative number. It does not live in the negative space. Okay, so hopefully that makes sense. So now I'm just going to use order of operations. So order of operations here says that I'm going to do minus 16 and minus 16 on both sides, and that disappears. And so I end up with negative x squared is greater than or equal to negative 16. Now I'm going to divide both sides by a negative 1. Well, if you remember, when you divide by a negative, your inequality sign flips. So it used to be greater than or equal to, now it's going to be less than or equal to. So it's going to flip the sign when we divide by the negative. So that means that this is x squared less than or equal to 16. Now I'm going to get rid of this squared by taking the square root of both sides. So the square root of an x squared is less than or equal to the square root of 16. Well, the square root of x squared is an x, and the square root of 16 is a 4. Now, if you'll notice, I've now added the absolute value signs. And this is because when we have like the square root of 9, technically, remember, our 3 times our 3 could equal the 9, or the negative 3 times the negative 3 could equal the 9. And we have to consider both scenarios. So that means that we're going to rewrite this twice. We're going to consider this first scenario, and we're going to consider the second scenario. So the first scenario is going to be x is less than or equal to 4. And that's exactly as it's written. X is less than or equal to 4. But the second scenario is x is flip the sign, flip the sign. So I've just flipped the sign. So x is greater than or equal to a negative 4. But again, do you see that? I flipped this sign and I flipped this sign. This was less than and it was a positive. Now it's a greater than and a negative. So I'm flipping the sign, flipping the sign. So these are the two scenarios that I need to consider because of this idea that both of these numbers can be factors of 9. So now I'm just going to, okay, so actually we're finished, because that is basically telling me that the x's are less than or equal to 4, and the x's are greater than or equal to negative 4. So how can we kind of put that in a situation where we can then put the interval notation? Well, let's put it on a number graph, number line. So I've got my negative 4 right there. I've got my positive 4 right there. And it says it can be equal to them. So that means it's closed circle and closed circle. And it is less than the 4. So here's the 4. So it's going to be less than the 4. And then it says over here that it's going to be greater than the -4. So from the -4, it's going to be greater than. So that means it's going to be everything in between those two numbers. And now it is kind of easy for me to create my interval notation. And these are the x values. So that means this is the domain, right? This is the domain. And the domain from left to right. Here's the left side, and here's the right side. It is going to be -4 to the 4. And of course, we do put the brackets on there. So the domain is going to be equal to the interval from -4 to +4. Now, is that exactly the same thing that we found when we looked at it from the perspective of the circle? Yes, it is. Okay, now we need to figure out how we can find the range. We found the domain. Now, how can we find the range? Okay, so this is my function right here. And I can do it by hand by setting up a little table of points if I'd like. So given the fact that I had the domain included -4, it included 4, well, I've included -4 as an x value and 4 as an x value, and 0 is right in the middle. And so when I put that into my function right here, then it pops out my y values. So I will end up having the point -4, 0, 0, 4, and 4, 0. And I can plot those points. So there's a point, there's a point, and okay, let's see if I can draw this straight. Oh, nope, that's terrible. Let's try it again. Okay, we're just going to pretend like that's a perfect half circle. Okay, but that is the point from -4. That's just connecting those 3 points with a curve. Okay, so and that's of course the same as the graph that we got when we were talking about the half circle up here. Okay, so that means we need to think of the range. Again, are the y values, BALUES, and that is also from the bottom to the top. Okay, so again, our bottom of our graph is right here. The top of our graph is right here. The bottom is at 0 and the top is at this 4. So the bottom is at 0, the top is at 4. So that means that my range goes from the bottom value of 0 up to the top value of 4. And it is equal to that 4 and equal to the 0. Those points are actually sitting on 4, 0 and -4, 0. So anyway, that is our range values uh, on the interval from 0 to 4. We could also, instead of doing this by hand, we could go to Desmos. And over here, you can't see it, but over here to the left, I've already put in y equals square root of 16 minus x squared, and it did give me this graph. It confirms that that is the graph. And of course, we can see the domain is from the left side to the right side, from -4 to 4, and that's the domain. And the range from the bottom to the top is going to be from 4, or I'm sorry, 0. The 0 are the y values, so 0 up to 4. So 0 to 4 is bottom to top. Okay, so let's go back over here. I think that we've talked about everything we can talk about with this problem. So hopefully that helps you understand more about the square root function. It's just really important that you understand that the square root function, it ceases to be a function if we were to finish this out. It's like if we drew it like this and it looked like a parabola on its side and it existed in this negative space, well, if we did the vertical line test, it would not pass the vertical line test because it's hitting at 2 spots, which means that's not a function. But they clearly told us that this is a function, that this function, the square root function, is a function, which means that it cannot live in this bottom space. It can only live in the positive space. Okay, so you just have a great day. Come back the next time. And if you want to, click that like button. Okay. Bye.